Guys, today we're talking about constant proportionality, and we're specifically going to look at examples with graphs. So before we take any notes or do anything, I'm going to show you a couple of examples and talk about a few things before we get started. So this is a flow chart, and it shows us how to determine if a graph is proportional or has a proportional relationship just by looking at the graph. So if you look at this flow chart, the first question says, is there a constant rate of change? This means the points form a straight line. So if you're looking at a graph and I'm looking at this line, I'm really just looking, is this line straight? If it goes in a straight diagonal line, sorry for my drawing there, but the red line itself, it is straight. Even though it goes diagonally, that's okay. We just need a straight line. So that's our first question. Okay, so since our graph does point or form a straight line, we're going to move to the next question. We're going to follow the yes. Okay. The next question asks, does the line pass through the origin, which is at point 0, 0? So if we go down to this graph, I see that it does in fact start in that corner there at 0, 0. Okay, so we always have to start at 0, 0. And if we answer both of those questions, if they're both answered yes, then we know that there is going to be a constant of proportionality. Okay, so we haven't done the hard work yet. We're just looking at this to decide if there's even going to be a constant of proportionality. So in this example number 1, there is a constant of proportionality because it meets the criteria. Okay, if ever you answer no to any of these questions, okay, so if you're saying, hey, no, that's not a straight line, then there's not going to be a constant of proportionality and you're not going to have to do all the math that goes with it. Okay, or if it does not start at 0, 0, but it is a straight line, but let's say it starts somewhere up here, okay, since it doesn't start at the origin, it's not going to be a proportional relationship. Okay, so let's practice this a little. I'm going to show you some graphs, and you are just going to decide if they're proportional or not proportional. So number 2, I want you to look at number 2. Oh, sorry, there's a dot here. I want you to take some time and look at this and decide if you think it would be proportional or not proportional. Okay, this one is not proportional. So it meets one of the criteria because it has the straight line. Okay, my drawing is not a straight line, but the actual line was straight. So then that moved me on to my next question, which asks, does it start at the origin? Does it start at 0, 0? Does it start down here? It does not. So that means that we have to stop. We can't go on any further because this is not a proportional relationship, and therefore it will not have a constant of proportionality. Okay, third one, I want you to go ahead and take some time thinking about this one and think if it is proportional or not proportional. Okay, this one is not proportional, and I can tell right away that it's not proportional because this is not a straight line. Okay, it kind of zigs and zags. So when that happens, I can stop right there and say this is not going to have a constant proportionality because it's not proportional. Okay, number 4, go ahead and take some time, think about this one. Okay, this one is proportional, so it will have a constant of proportionality. It is proportional because it starts at the origin, it starts at 0, 0, and then this is a straight line, so it is proportional. Last one, number 5, go ahead and look at this one. Okay, again, this one, it kind of has this zigzag line. So right there would stop and tell me that it does not have a proportional relationship. But this one's a double whammy because it also does not start down here at the origin. Okay, it starts up here. So for this one, there's actually 2 reasons why it's not proportional. Okay, so we're going to go ahead and go on to our notes. We're going to take out this foldable that we were given. And we're going to fill in just the middle section today. So we're going to fill in the section that has the graph in it, and we're going to talk about how to find the constant of proportionality after determining that it does have a proportional relationship. So go ahead, take that out. You're going to write on the top of your foldable in the top section where it had some extra space. You're going to go ahead and write in there. I'm going to move this down just a little bit. And then we're going to go ahead and write some notes about these. Okay, so first thing about graphs is that you have to decide, is it proportional? Okay, so I want you to look at the graphs first and even decide if it has a constant of proportionality. So this is going to be what we just practiced, deciding if the graph is proportional. Okay, so what that means is that when I'm looking at this graph, I'm seeing that it starts at 0, 0, so it starts in the origin, and it has that straight line. So therefore it's proportional. It will have a constant of proportionality. Okay, so then if yes, then we need to find the constant. I'm going to abbreviate here, constant of proportionality. Oops, sorry. Okay, and for this graph, it's a little bit more labor intensive of finding the constant of proportionality from than like a table or a chart or even from an equation. So this is going to take us some extra steps, and that's why I want you guys to decide if you even have to do that work by deciding if this is proportional. Okay, so if we know that the graph is zigzag, then we know it's not going to have a constant proportionality, and we don't have to do all this work. Okay, but since if this graph is proportional, we're going to have to do some of this work, okay? So what I need you to do anytime you're trying to find the constant of proportionality from a graph is find these easy to read points, okay? And by easy to read, I mean that the points meet in a corner. Okay, so if you're looking at all of these, you see that they all are in the corner of the boxes. Those are easy to read points. Okay, that means that I could easily go over 1 and up 3 to get to this point. So I know that this point is at 1, 3. Okay, and I think I should have mentioned this before, but anything that I'm writing down, I want you guys to write down so you have it in your notes, okay? The next easy to read point is over 2, up 6, so this is at point 2, 6. Okay, the third point is over 3, up 9. So this is at point 3, 9. Okay, fourth point is over 4, up 12. And then the last point is over 5, up 15. Okay. If at any point you need to pause the video and catch up with the writing, you can do that. This is meant to be able to work at your own speed. So if you need to pause something, if you need to listen to it again, you can rewind and do that as well. Okay. So now that we have all these easy to read points, we have to find the constant of proportionality. Okay. To find the constant of proportionality, we have to go back to finding the unit rate. So to find the constant of proportionality, I want you to write this down. You're going to take the y value divided by the x value equals the unit rate. Okay, so when we're talking about coordinate points, okay, the first number is always your x value, and the second number is always your y value. Okay, so just like when we were looking at a table or a chart, the first set of numbers are your x values, and the second set of numbers are your y values. That's the same for coordinate points. Okay, so we have to do something different, and to be able to find the unit rate, we have to take our y value divided by the x value. So in this case, it's going to be 3 divided by 1. Okay, and that equals 3. Okay, but it's not enough to just find that for one of these. We have to find it for all of these. Okay, so when I take the second point, I have 6 divided by 2 equals 3. Okay, 9 divided by 3 equals 3. 12 divided by 4 equals 3. And then the last one, 15 divided by 5 equals 3. Okay, so we have determined that the unit rate for all of these points is 3. So now, just like we did with tables, we have to write our unit rate as the constant of proportionality by writing it with labels. So write out the constant of proportionality with labels. So that will be our last step. Okay, and we've already done the hard work, so this part is actually the easiest part. We're just going to write this out, 3. And then if you remember, I switched this order, so I need my y value first, which is over here. Okay, these are my y values. Maybe if you don't remember that, ooh, that was a bad y. If you don't remember that conversation or don't remember this from elementary school, maybe you want to write this down. Those are your y values. These are your x values. Okay, so since my y value was the first number in my division question, I'm going to put that label first. So this will be $3 per, oh gosh guys, sorry, this is really hard to write with a mouse. And then my x label, which is pounds. So it's going to be $3 per pound. And then this here is our constant of proportionality. Okay, so that's everything there is to know about finding the constant of proportionality from graphs. We're going to continue practicing this shortly, but actually for now what I want you to go ahead and do, I'm sorry, I'm moving this, is I want you to find this half sheet. If the guest teacher did not already give this to you, I want you to go and get it. And we're going to practice just writing out what points mean. Okay, so if you need to pause your video to get this worksheet, go ahead and do that. Otherwise, I'm going to start talking about what I mean when I'm saying what I want you to tell me what a coordinate point means. So I'm going to start at number 1. So the first thing says write the ordered pair for point A. So I'm finding point A, which is right here. And when I write this as a coordinate point, I always have to go over how many spots it is over, comma, how many spots it is up or down. Okay, so how far does it go over compared to how far does it go up and down? So when I'm talking about point A, I see that it goes over 1, so that's going to be my first number, and then it goes up 3, so that would be my second number. So this ordered pair is 0.13. Okay, and now what I'm really interested in knowing is what does this coordinate point mean in terms of this situation? So this is where I'm going to have to look at my graph and my labels. Okay, so what does point A mean in terms of this situation? So if I'm following the ordered pair, I went over 1. Okay, so that means that label for X is days. So that means in 1 day, okay, and then it went up 3, and the label for that 3 is books. So in 1 day, we don't know if they're reading or writing or what they're doing. So we're going to say 1 day for 3 books. Now that kind of sounds silly, and it's kind of actually, it was hard for me to say that. So what I could turn this into, I'm going to turn I'll leave that black. is I can just reverse the situation and it would still be true if I stated this a different way. So how I could state this instead is I could say 3 books per day. And when we say that, it kind of just sounds better. It sounds more grammatically correct. And that's because that's the unit rate, okay? So even though we're at 0.13, we can switch the way that we say it and say 3 books per day. It would mean the same thing as 1 day for 3 books. Okay, I want you to go ahead and do 3, 4, 5, and 6 yourself. If you finish this, I want you to go ahead and turn it into your class periods bin. If you do not finish, I do want you to hang on to it and try to get those done before we come back to class. Okay, thanks so much for listening.